Hello class, today we're going to be talking about some advanced object-oriented programming techniques and concepts. The four major object-oriented programming or OOP concepts that we're concerned with are abstraction, encapsulation, inheritance, and polymorphism. And I like to think about transformers when I'm thinking about object-oriented programming because a transformer, you can tell, is built of a lot of different pieces that could be objects. We won't go down to that level, but they can transform or morph from one thing to another. So if we were thinking about a transformer base object that contained the basic data that all transformers have and the basic actions, we could create a transformer class. And then from that, we could derive additional classes that added additional pieces of data or actions or abilities to that base class. For example, we might have Autobots, Decepticons, others. We could even inherit from that object even further. So we could say that a prime was a type of Autobot. An Autobot is a type of transformer. This inheritance of objects gives us a lot of capabilities in object-oriented programming. If we think about a transformer and the kinds of things they can do, we can walk and drive and transform, maybe attack, defend, roll, kick, so many things. Now, some types of transformers might use different implementations than other types. So we might have something that can walk, something that could drive. We might override that in another place because one type of transformer may go about walking a little bit differently. So we could have some different implementations of that same method. The methods in our class are the actions associated with our object. Our class also has data or characteristics associated with it, like name and function and title, number of weapons, type of weapons, weakness, what kind of state the transformer is in. Notice that some of these data elements or characteristics or attributes have plus signs and some have minus. Some of them will expose to other classes, and others we'd like to keep private. Excuse me. For example, our weaknesses, we probably wouldn't keep those private. We would just be handing that information out to just anybody. So working with object-oriented programming and these concepts, the first one is abstraction. These are abstract pictures. Can see there's some lights, can't see exactly what's going on there. So abstraction makes essential features available, but it hides non-essential complexity. So we might say a transformer could use its transform method to turn into its alternate form, but the actual mechanics, how that happens behind the scenes, could be hidden or abstracted. Here's an abstract class definition for a transformer. When I declare a class abstract, it cannot be instantiated as a new object, but it can be used as a base for a class structure. So we'll say our base transformer has a name, the number of weapons, and type of weapons as data elements that he carries, and he exposes those to the outside world through public properties, getters and setters. I left that code out so that we wouldn't have too much to look at. Now, although this class is abstract and we can't actually create an instance of it, we still need a constructor to define what kind of data elements it requires as parameters to construct a proper object. We'll see why later. In this class, we could override external methods, the transformer class, inherits by default from the system object, so we can still override the system object toString to generate a string value for this transformer instance, even though we can't have one. And then we can create virtual methods, and a virtual method is one that we have in our base class, but by labeling it as virtual, we're keying that it can be overridden. Another special type of method that we could create is an abstract method. Just like an abstract class, it's not got enough information to create an instance of it to run on its own. All it is a method header, a method definition, ending with a semicolon. So there's no method body in our open and closing parentheses to implement this method. It's been labeled abstract. It must be implemented by classes that inherit from this transformer base class. So our abstract class cannot be instantiated. It's like a high-level template of the class. We can override other methods, which is in effect polymorphism. We can create virtual methods that can be overridden by others, and we can create abstract methods that are method headers that say this method must be implemented by any children or derived classes. The next concept is encapsulation. Here we have a piece of earth that's been encapsulated in this clear substance, and so it's stuck inside of there, encapsulated. Here we have a piece of paper that's going to be laminated. We have some laminating sheets on both sides that are going to be affixed to the paper, then it will be encapsulated inside of that lamination. Here we have a phone. This abstract component of the phone is showing on the outside. We know it's a smartphone, but internally all of this hardware is encapsulated within this abstract case layer, so we can see how encapsulation works. If I have a class and I have my private class fields, those have no exposure, nothing outside of my class can access those. But if I expose them using public properties or getters and setters, then external classes can access that data. In the same sense, I can have private methods within my class that are hidden actions that are only available to other methods within the class. But I could also have public methods that are available to external outside sources, other classes. These are processes or actions that could be controlled by those external sources or executed by. Now, all of this information is encapsulated within the class. So the class itself is encapsulating and hiding all of these details so that nobody else needs to worry about them. They're taken care of. Don't need to reinvent that wheel. It's been done and it's been encapsulated. So encapsulation is creating a package that has the data and the behaviors into a single unit. It hides those implementation details. So in our transformer example, each transformer has states and attributes like the color, type of weapon, type of movement, and each transformer has behaviors like transform, roll, and attack. So all of those details of how those attributes and behaviors interact are hidden inside that class or encapsulated. Inheritance is a concept that's similar to inheritance that we think of, inheriting money, inheriting characteristics from our parents. Here's some Simpson scenario. We have Marge and her sisters, and her parents, we don't know much about her dad, but if we look at them, some things that we could imply is that they all have a forward sloping posture, so that's probably something that's inherited. Marge and her mom have similar hairstyles. They say, well, that's probably not inherited, but I would say the propensity to be able to create that kind of hairstyle has to be inherited, right? So some inheritance going on. And when we think about a family tree, you know, these kinds of traits, characteristics, the family data basically is It's passed from generation to generation. So we can see, how people look similar. Back to our Simpsons scenario. What about their kids? They'll have spiky yellow hair. Marge sure doesn't, and Homer, no. But Grandpa Simpson does. So sometimes our inheritance may not be directly from our parent. It might be from a generation prior to that. So taking that to our Transformers class, our Transformer class would be our superclass or parent class. In C# we'll refer to it as our base class. The Autobot, Decepticon, and other would be our derived classes or child classes. Our next layer down would also be derived and child classes, but they would basically be grandchildren to the Transformer class. Now, if I create an Autobot, that Autobot is going to have access to all its data and methods, and it's going to have access to its base class data and methods. And in the code, it would look like this. Our Autobot class inherits from the Transformer. We would probably have public here. Now the colon and then the base class name indicate this inherits from relationship. In our Autobot, we have some different data elements, our private class fields, than we had in our Transformer, of course, because remember, we're going to have access to those properties for the Transformer, so we can get that information. Then next, we would have our properties for these Autobot data items, whatever we want to expose. In our Autobot class, then, we would need our constructor, and our constructor would specify, first of all, parameters that are new data types to this Autobot class. So our Autobot, we need the type of auto, number of wheels, and the type of vehicle. But then in our constructor, we would also refer to the base class and list each of its parameters. So if I call this Autobot constructor to create a new instance of an Autobot, I'm going to need to pass all of these parameters in, the base class parameters and the derived class parameters. In my Autobot class, I could continue to override the toString if I wanted. I can override that attack method that was set in the base class as being something that could be overridden, and I must implement that transform class because it was set as abstract in my base class, so I have to have an implementation for it. So not too much different than a regular class. And now this Autobot class, like I said, is going to have access to all the properties and methods available from the Transformer class. That inheritance allows us to reuse code. Our Transformer class could be extended to create any type of Transformer, and we might create a new type of Transformer child class that has different characteristics over and over, or we might just have 2 or 3 and that be all we need. Derived classes then contain all the data and methods of the parent class, plus their own data and methods. Polymorphism. We've got some little bit of dictionary.com action here. First of all, what in the world is polymorphism? Well, I have a butterfly here evolving, and I wanted you to think about where this word comes from, because it can be kind of a big word. First of all, to morph. To morph means each of several variant forms of an animal or plant, some sort of object, right? And then poly, in the sense that we're using it here, says it denotes the presence of many. So we're going to say that it could be many forms, polymorph. So polymorphism is being able to take many forms. So if I look at my transformer contained that abstract method, transform. Because it was abstract, we said any derived class that bases itself on the transformer class has to implement that transform method. So the Cybertronians, the other here, they have to implement their own transform method. Dinobots have to implement their own transform method. So notice how the transform method can morph. It can morph from one thing to another. So in our other Cybertronian class, we might have one implementation of the transform method, and for a Dinobot, we might have another implementation of the transform method. They're all transformers, but that different implementation, the ability to create that different method, creates that polymorphism. In another example, my Autobot could override that attack method. Remember, it was set is a method that could be overridden. So if I do override it, again, I'm implementing polymorphism because I'm changing the way this reacts, the way that object type handles things. So polymorphism is multiple implementations of the same behavior. So the appropriate implementation should be used based on the situation. And for our transformers, when we move, we might be rolling, we might be walking, we might be flying. So we would have to use the appropriate code within a move method. So our move method would have to be overridden. So a class is a noun, a transformer is a thing. A child of a transformer, like an Autobot, is a transformer. Instantiating a class creates an instance. So Bumblebee is an instance of an Autobot, but Bumblebee is a transformer. And data, our class fields and properties, is encapsulated by the class. So a transformer has a name. And I want you to be thinking about those classes and properties. A class is a thing. An association, where we're talking about a data field that's associated with a class, is a has-a relationship. A transformer has a name. A transformer has a type of weapon. Now, a composition relationship is a type of relationship. So a child of a transformer, like an Autobot, is a type of transformer. It also is a transformer, so both of those relationships are true. But composition relationships could also mean a part of. So the name is a part of the transformer. So all of these different types of relationships are just different ways for us to verify that our design is correct. I should be able to look at any sort of design diagram that I have and say, let me back up here. Back up. Where's our picture? I should be able to use these methods. A Decepticon is a transformer, an Autobot has a name. So I can walk through all of these different diagrams and say these relationships and make sure that things are set up properly. Because if I'm running into a problem with these relationships as I try to say them, then there's probably a design error. Okay, so I've got this Autobot class. Here's my constructor. I say that a public Autobot needs a string that I'm going to call a type. It needs an integer that I'm going to call WHL, that's my number of wheels, and it needs an integer that is type of vehicle. I might have that wrong. We'll see. I'll get a compile error, right? And then the Autobot uses a base class. So I've got to put this semicolon base, and in parentheses, I name all of the parameters that are going to be passed to the base class. So this in the green is in my Autobot class definition. Now, out here, I want to use that class. I want to test it. So I'm going to create an instance of an Autobot. I'm going to use the class name Autobot. If I can't see my class, if Visual Studio is giving me a bunch of errors about the class, you need to check some things. Make sure that the namespace name is the same. That's going to be a big one. There are some other things that you can do that they refer to more in our chapter, but it could be a problem. Just make sure that your namespace name is the same. So here's my class name. Now when I create an instance of my class, I give it an instance name. This will be BB. And I say this is a new instance of an Autobot. And here are the parameters I want to use to create that Autobot. Notice the parameters that go to my base class are listed first, and then my parameters for the derived Autobot class are listed second. If I want to use the getters, then I could say I'm going to declare a string name, hold name, and I want to set that equal to BB's name property. That would call this name property and use the getter. So we would return whatever the name data field was from our class. I also could say that I wanted to declare an integer named numWheels and use it to get the property for the number of wheels. It would have the same type of getter and setter. Now if I use the setters, I'm saying I want to take BB's name property and update it and set it equal to the value of whatever's in hold name. Well, when I do that, again, dot name is going to refer to the name of the property in my class. And then this value here, hold name, is going to be passed in to this variable named value, this magic value that's in our getters and setters. And that's just happening behind the scenes for us in C#. But that's how those connections are made then. So, advanced object-oriented programming, it's awesome. It really does give you so many capabilities, and that's why object-oriented programming has been in use for so many years. The code is simple. It's really not that bad, but the terms can be harsh. Remember that abstraction is getting down to the most basic pieces and hiding the details. Encapsulation is the process of hiding all of those things within a class, the data, the methods, all of the details. Inheritance is using the basic details and adding more. Some new stuff comes out. And polymorphism is being able to use the same code for multiple forms, like I could use the same method name transform for all my different types of transformers. And so that's going to give me that ability to have that polymorphism. It's great stuff. Get some practice. We have a lot of great examples in your text, and I'm trying to create some more videos for you. Thank you.